Hello, I'm Reggie York. This is a presentation on using a special Excel file I have developed when you want to compute data for using the paired t-test when you have matched scores, like your pre-test, post-test, one group design kinds of scores. This is an illustration of how to use this special file. Um, it's available from the book I've done entitled Statistical Analysis of Data for Human Survey Evaluation. If you have that book, this file is available to you. This presentation relates to quick guide number 1 from that book. Here is the quick guide, by the way. If you want to review it, I suggest if you want to review it, you can hit the pause button, read this to get a little bit of an orientation, and then come back to me. Okay, I'm assuming you've done that. Now let's move on. What you need to do to prepare to use the Excel file, the special Excel file, you'll prepare your data in this particular fashion. You see here we have pre-test score for client number 1 is 12, post-test score is 15, the gain is 3. This is a pre-test score for self-esteem, post-test score for self-esteem, with a tool that makes higher scores represent better self-esteem. So if you go from 12 to 15, you have a gain of 3. However, client number 2 had a pre-test score of 18, post-test score of 17, which means they went down 1 point. So they get a gain score that's actually -1. So that's how you compute it. If your instrument gives better scores for lower scores, you would do the opposite in terms of what you would subtract from what, so that the gain always represents improvement. Now, you will not enter client numbers in this particular file. You will only enter pre-test, post-test, and gain. Okay, let's move down to this particular information. When you get the file, I'll show it to you in a moment. There's a cell for the value of P. Of course, P tells you about statistical significance. You'll also see a value of T, which you should report in your report of your study, but it's only useful for coming to the value of P, so I will not discuss it further. There's a cell that reflects the effect size, which is the number of standard deviations of difference between pretest and post-test scores. If you see it as a decimal figure like 0.34 or 0.67, it is a percent of a standard deviation. So that, for example, an effect size of 0.50 means that the average post-test score was 1/2 of a standard deviation better than the pre-test score. Naturally, effect size of 1.0 means it's 1 standard deviation better. This will tell you something about practical significance, which is discussed in the book. I want to give you a caution here. You might get a strange figure in one of the cells. For example, the p-value may display a number that has e dash something. Let's look at this example. You might get a number like 1.845 e-07. You wouldn't report it this way. It's not a p-value of 1.84. E-07 refers to the fact that you're supposed to move the decimal point 7 places to the left. Therefore, an E of, if you see this particular figure, 1.845 E-07, the actual p-value, or the value, whatever it is for that cell, should be 0.0000001845, because the p-value has been moved 7 places, from right here all the way over to here. So that's your p-value there. If you see this, your p-value is actually that. Of course, you would normally report your p-value, something like p less than point, whatever there. Okay, Here's the data we're going to enter when we put up the Excel file for you. We got pre-test scores, post-test scores, just like we showed in the previous thing. So now we'll look at this file. Here we have pre-test score 12, post-test 15, a gain of 3. I just got through entering these a moment ago. The second line is for the second client, 18, 17, negative 1. Third client, 14, 17, and a 3. Fourth client, 12 for pre-test, 19 post-test, a gain of 7. Now here's where you're going to look for your critical information. The mean pre-test score is 14. The mean post-test score is 17, which means a gain of a mean gain of 3. Here is one of the most important things to look at, the value of P. Here we have a 0.0817. If you are using the standard in the social sciences of 0.05 for declaring statistical significance, you'll find, of course, that this particular data did not achieve statistical significance. If you have a different standard, it may be different. Here's the effect size, 1.22. By the way, ignore the negative sign in front of it. That's an artifact of how this thing was configured, but it has no meaning. We have effect size 1.22, not negative 1.22. Okay, well, I hope that has been beneficial to you. I want to say one more thing. If you have more than 40 cases, you cannot use this file. These special files that I put together are designed for small samples that human service practitioners may actually do when they're working with their own clients, usually small samples, or students who are doing their own collection of data with their clients and so forth. It's not designed for the scholar who has major databases, which may be better served by something like SPSS, which, by the way, is also illustrated in the book that I have prepared. So I hope this was of benefit to you. Good luck.